The statement of requirements for this RFQ. Today's date, April 16, 2020. The due date for this RFQ, May 15, 2020 or sooner. Dear Madam, dear Sir. Your company has been selected as a potential bidder for the subject injection molds. You are expected to meet all of the requirements of this RFQ. Be certain to read all documents carefully and send your response in electronic format to the Amer Tooling Manager Amer Janineh. You can contact Amer Janineh at email address amer.janineh@yahoo.com. Phone number 810-542-2779. This RFQ and attachments are not to be shared with other organizations, except as authorized in writing by the Amer LLC. Tooling Manager. Failure to submit a quotation in a timely fashion, or failure to respond to this RFQ in a complete, comprehensive manner, may result in your quotation not being considered. For those declining to quote, reply no quote. Payment terms. First payment 1/3, 10 days after received the invoice and mold design is approved. Second payment 1/3, 10 days after received the invoice and approved first samples with good dimensional report. Third payment 1/3, 10 days after received the invoice and mold is approved ready to ship to the USA or our facility. Note: most likely the first and second payments will be combined and paid in full 10 days before we ship the mold to the USA or to our facility. Quoting requirements. To include contract payment terms as noted above. To include delivery time and cancellation terms. To include lead time for first shot. To include lead time for tuning, 1, 2 and 3. To include cost for 50 shot from first tryout. To include cost for 3 tryouts 50 shots each tryout. To include cost for tool run off 500 shots final tryout. Tooling cost is to be separated from the tryouts costs. Detail of the injection mold warranty must be included. Injection mold production capabilities must be estimated and outlined in quote. Cycle time and press tonnage to be estimated and defined. To include cost for shipping tools, option number 1 FOB nearest port, option number 2 door-to-door, for air and sea. Quotation must include a line item breakdown of all costs to build the new injection mold at your location, including a list of all the locations, countries, cities, states, etc., you are planning on using for the tool construction, for all component tooling and final assembly. Who will build it, where you will build it, and where you will buy it. Quote must include an statement of adherence to this specification and include an itemized list of any exceptions taken to this specification. This RFQ is for one fully automatic custom-built production mold. The mold must be designed and constructed per Amer mold requirements and as detailed below. Precision molding and mold construction are required for this tool. The surface finish for cavities and cores, SPI, B1. Part 3D CAD file name, 105C. Part 2D file name, D105C. Tonnage, mold must fit in angle, 85-ton press. Please approximate the required tonnage for each option. Cycle time, less than 36 seconds. Approximate part size, CAD. Wall thickness, CAD. Mold base, see next page. Molded material, PA66. Estimated annual volume, 250,000 parts, mold life, 5 years or 1,250,000 shots. See next page for cavitation. Mold type SPI, 101 mold. Cycles, exceeding 1 million. Description, high production mold. The molded parts requires tight tolerances. Mold shall be built to produce 1.5 CPK quality parts. The required dimensions. 4 CPK will be selected by the Amer quality engineer and the customer. 2D drawings, 30 parts capability report is required. CMM inspection report of the cavities and core steel are required. CMM dimensional report of 5 parts of each cavity is required. Cost for the CMM reports to be separated from the tool and the tryouts cost. The cost breakdown form is included in the RFQ package. Please send us an email if you cannot find it. This is an example. Please quote these two options. Option number 1. Mold cavitation, 4 cavities, production tool with cavity and core inserts, fully automatic. Fill system for option number 1. 2 hot drops, Inco hot runner system. To cold runner, to tunnel gate. Option number 2. Mold cavitation, 2 cavities, production tool with cavity and core inserts, fully automatic. Fill system for option number 2. 1 hot drop, Inco hot runner system. To cold runner to tunnel gate. Steel type for the cavity and core inserts for options 1 and 2. AISI, H13, 48 to 50 RC. All sub-inserts must be made of mold quality AISI S7, 58 HRC. The supplier must use Finkel steel for both options. Mold base for both options, DME number 2 or equivalent. Mold type SPI 101 mold. Cycles, exceeding 1 million. Description, high production mold. For molded part requiring tight tolerances. For this RFQ the supplier must provide 1 DFM and dimensional feasibility reports. 2 approximate tonnage. 3 approximate mold size. 4 approximate mold weight. 5 number of slide, lifters, tunnel slides and side actions. 7 must ensure that all slides and lifters angles must not exceed 12 degrees. 8 must confirm that this tool will be designed and constructed with normal tool action and standards. 9 cost breakdown and lead time. If awarded, the supplier must provide 1 steel certificate. 2 maintenance manual. 3 list for spare parts. 7 declare warranty for each component, as shown in the included warranty form, Excel file. 8 certificate of origin. 9 dimensional report of the mold steel and the molded parts. 10 all documents as listed in the Amer LLC mold requirements. Note: all tooling to be built using USA Inch. Standard components including screws and ejector pins, those are the approved suppliers for the Finkel steel in China. Tuning of the mold. These tool modifications are not an engineering changes, but are considered part of the tool build process to comply with fit and dimensional requirements. The supplier is responsible for the cost. The mold supplier must ensure all molded parts are within the required dimensional tolerances as shown on the 2D drawing. The mold supplier must use fine precision steel tolerances for the mold construction. See the 2D drawing PDF file I have included in this RFQ. The molded part 3D data is master. However, the supplier must inform the mold buyer if the 3D data does not agree with the dimensional requirements shown on the 2D drawing. Please review both the 2D and the 3D part data and advise for dimensional discrepancy and feasibility. Runners and gating. Full round runners are preferred. If not possible, a modified trapezoidal runner is acceptable. Sharp corners are to be avoided. Radius all corners to the diameter of the runner. Runners to be polished to a SPI number 3 finish without cutter marks. The gate type, number, and location will be agreed upon during design reviews. Where possible, runners are to be stamped with resin identification, i.e. ABS, PC and ABS, PP66. It is the tool shop's responsibility to assure that gate location, style, and size adequately fill to produce an acceptable part. The mold supplier is responsible to provide a mold that produces a visually approved part that is to print. Any deviation from part to print must be in writing and kept as a permanent part of the mold construction records. The tool builder must use the plastic resin manufacture process parameters for all the tryouts. All molding process temperatures must stay below the maximum temperatures set by the plastic resin manufacturers. The tool builder must make sure the hot runner system is wired per the hot runner manufacturer. Electrical diagram. The tool builder must not use like steels on details that wear against each other and typically. Observe the rule of having 10 points RC hardness difference as well as using good shutoff angles. You must be mindful of vulnerable shapes and high wear areas and try to sub-insert these portions when feasible. Also, recommend limit switches, early ejector return systems, accelerated ejectors, as well as other components and peripherals when you believe they are necessary. You are the tool builder and the tool engineer. 1. Pay attention to details. 2. Be creative. 3. Think logically. 4. Our best preparation for tomorrow is doing our best today. Workmanship. Tool construction, to a standard that ensures durability and stability, for continued use in a plant environment for the life of the part and must include a warranty of materials and workmanship for 100,000 shots or 1 year from shipment from your facility, whichever comes first. Responsibility. The tool supplier is 100% responsible for the fit and function of this injection mold, and the Amer team will not approve the tool for full payment until after the tool is 100% production ready. If deviate from purchase order, must inform the Amer purchasing department immediately of any differences. Tools shall not be built or modified to a level beyond which a written purchase order exists and defines. Design approval and waiver. Design approval shall not constitute a waiver or guarantee of responsibility for any tool purchased by Amer. An approved tool design does not constitute a certified or an approved tool. Design reviews. All tools design shall be submitted to Amer for final review and recommendations at a design conference or at designated meeting. Documentation and drawings. All designs are the property of Amer. Detailed tool designs are required. Each submission of the tool designs to be accompanied with STEP, PDF and DWG files. A final copy of the tool designs and drawings to be supplied on or before you ship the tool to Amer facility. These are the required formats: native 3D and 2D files, STEP, PDF, and DWG files. 2D full design is not mandatory unless otherwise specified. When 2D full gauge design is required, a copy of a PDF, native, and DWG files shall be submitted. Bill of material is required. Alternatives. As a part of this quotation, you are encouraged to offer alternative part designs to achieve better injection mold parting line shutoffs, part design DFM, part quality, cycle time reductions to our specified request, especially those that include off-the-shelf components or industry standards, but still fulfill the required function. Tool designs, and purchased components. The responsible tooling engineer, representative of Amer, shall review the tool designs, providing recommendations and comments as required. All tool designs shall be submitted to Amer for review and recommendation at a design conference or at designated meeting. Supplier shall not buy tool steel or components until after the tool design is approved by the Amer tool engineer. It is the supplier's responsibility to record all changes to the design during the mold construction and to subsequently update the original design tracings. The supplier has the final responsibility for tool modifications or corrections in order to ensure that final operation and production produces part to print. Timeline and open issues. The tool source must submit a tool timing chart, showing detailed timing for each milestone event of the design and build process, within 1 week of receipt of the purchase order. This timing chart must be updated and submitted to the Amer tool engineer, weekly, and must contain at a minimum start date, duration, completion date, name of the responsible person for each task, date received PO, kick-off meeting, tool design concept review, tool design review. Final tool design review, by tool steel and components, tool construction, material. From Amer to your facility for the first tryout, date for the first tryout and the final tool run off at your facility. Weekly updates must include open issues, pictures and/or CAD files and drawings. Documentation of all events relevant to program timing. All engineering changes are to be documented by the revision level and date. Any change in delivery, with explanation of change, must be authorized in writing by the Amer team. Important reminder that due dates in contracts and timelines are not arbitrary and must be taken seriously. A failure to meet due dates will result in late fees, finance charges. Shipping charges includes expedite shipping charges to our customers. Expedite manufacturing charges includes costs for overtime, double time and outsourcing costs, and it can result in terminating the contract. The supplier will be 100% responsible for all costs accumulated from a late delivery of the tool. Supervision and inspection. The Amer tool engineer and his team reserves the right to visit the tool source at reasonable times and frequencies to inspect the tool and/or tool design during design and build phases. Review status of the tool and progress made towards completion. Ensure compliance with the requirements of this document. Attend tool tryouts. All changes must be authorized in writing by the responsible Amer tool engineer. Warranty requirements. Start date and period of warranty. Definition of supplied items included. Defined wear parts excluded providing defined lifetime reached. Labor included in warranty and for how long. Shipping and handling costs under warranty. Non-wear parts replaced to have separate warranty period of fixed price for spare and warranty parts. Spare parts, service, and software requirements. Supplier guarantee of availability of spare parts and accessories for specified number of years. Guarantee of availability of expert advice for the period as defined above. Customer service personnel supplied must speak the English and the local language. See our warranty document, Excel file, included in the RFQ. See next page. The cost and the lead time for components listed in this document will remain the same until after the component has reached its life expectancy as approved in this document. All freight, shipping and handling charges to and from mold builder shall be initially paid by the mold buyer. If determined to be a warranty repair, mold builder will reimburse such charges to the mold buyer. Components that are 100% warranted, the supplier will replace it free of charge. The bill of material must include the followings: part number, part name, catalog number, manufacturer name, supplier name, quantity, stock dimensions, life expectancy, warranty yes or no, warranty start date, warranty end date, components cost, lead time. Notes: all mold components are to be standard off-the-shelf components purchased preferably from DME. Custom-made items such as sprue bushings and locating rings are not permitted. The tool shop will need to get written approval if custom components are required. Unless otherwise specified, in the RFQ, molds will be constructed in either P20 or high-hard P20, particularly for cavities. Should high-hard P20 be required, it will be requested in the RFQ. Refer to Table 2 for common accepted tool materials and applications. Also refer to page number 5 for the required steel and mold base. Thank you for your time. My name is Amer Janineh and please watch my other mold design videos.